Hello, today I will explain the code. What is the time complexity of the following function? The purpose of the code, this function squares and the negative numbers in an integer array and returns the results. Array is integer array given to the function and is a first and elements of the array will be processed. The results is a variable is used to store the sum and is initially assigned to 0. The for loop from 0 to n minus 1 if in the less than the length of the array is the only first elements are the processed. If array I is negative less than 0, the value of Ri is a squared Ri product Ri. This value is added to the result variable. Therefore, is a time complexity is in linear time of the complexity. As since the loops runs the n time, each operation runs the O1 time. The results O1n, meaning the function runs linearly as the input array grows. And second, what are the time complexities of the following code the fragments? And the first loops from I equal 0 to increments I by 1, and total iteration n squared, and the times complexity or n squared. Second, I start the 1 and double each iteration I product 2. The loops runs while I smallest and 1, meaning the number of the iteration is determined by the largest power of the 2 that fits within n. For example, E1, 2, 4, and 8, blah blah blah. The n number the iteration log 2n is a time complexity or log n, and therefore the loops is it starts 0 and increase by 40 each iteration. Is since constants are ignored, big O nation, the complexity is O n squared, and for is I start n and is divided by 4 is a iteration. If n bigger than the 10, loops are the not execute. If n smallest than the 10, loops runs the constant number of the times. The time complexity or one constant time, and 5 is a I start the 0 and the increments by the n is each iteration. The total number of the iteration is a n, and the time complexity is a O n is a 6 is a the outer loops runs is a ignoring constant factors. The inner loops starts and m is the decrements by the 4 each iteration. The total iteration of ON product OM is the ONM, complexity of ONM. Okay. The for the I starts at 10 and increases by the 2 each iteration. The total number of the iteration is the O n squared. Therefore, O n squared is the time complexity. Is a time is the outer loops the multiplies by the 5 iteration. The number of the iteration of the outer loops log 5 n is a sum o m log n, and latest is this loops is exactly is the discrete theoretical sense is o n loops, and for o1 constant but very large. Okay, is a third. Is what is the time complexity of the following power function? Is a long recursive power is a long x and long n. If n equal 0 and return 1. If n equal is 1 is return x. If n two equal to percent 2 equal 0, return recursive power x product x and return the recursive part. Okay, let's analyze the complexity of the code. If n the function called in itself with parameters, and each recursive to call the reduce n and the so numbers calls can be a model using the recurrence relation analysis. And finally, time complexity is a O log n. The logarithmic time complexity is because each call performs O1 work multiplication and modulus check. So the overall time complexity is O log n. Okay. The what's the complexity is what is the time complexity of the following Fibonacci function? Is a Fibonacci function the calculates the Fibonacci number using the recursion. The Fibonacci sequence is defined as fn minus 1 and recursive Fibonacci n minus 2, with base case if f1 is equal 1, f2 equal 1. The function call it itself twice for n minus 1 and n minus 2, summing their results. The time complexity analysis is a recursive calls to total numbers and call grows exponentially, and better this is a memorize top-down the dynamic programming and repeated the calculation. The many Fibonacci numbers are computed multiple times. For example, recursive Fibonacci 3 is computed twice in the above 3. The experience the growth is recursive calls the or making the impractical of large values of the n. Also runs in on but with a better space efficiency of O1 space complexity. Finally, this complexity of the following is a calculate the Fibonacci numbers, but is a infrequent due to repeated the calculation is time of the O2n, which grows exponentially. Memorization or iterative methods are much better than alternatives. Latest is a faster computer of algorithm. Suppose we have a fast computer that is 10 times faster than a slow computer. We have a problem with two different solutions. Fast algorithm takes O(n) time, slow algorithm takes O(n) square time. Which is faster? Slow algorithmic running on fast computer is a fast algorithmic running on slow computer. Case slow is a algorithm is the slow computer. The running of the time constant are ignored by O nation. Is a O(n) squared on is a O(n) squared. Okay, we have problem with two different solution. Is it fast algorithmic text O(n) case the fast algorithm is a d product n time is a slow computer. D is a constant. Running its slow computer does not change because it's the complexity, so it's execution the time d product n. This means it runs in the O(n) time. Comparison O(n) squared with O(n). Even though slow algorithm runs on product faster on fast computer is O(n) squared. Complexity grows much faster than O(n) as n increases. Yeah, slow algorithms is the value of the and the fast computer might compensate of the initially of slow algorithm. However, the large and is the quadratic term dominates, making the algorithm significant. Is that the fast algorithm is the running of the computer is the fast algorithm running of the slow computer. Finally, fast algorithm running on the slow computer and becomes and grows much slower than n for very small values of the n because slow algorithms on the computer might be competitive, but the fast algorithm always win. Okay, thanks for listening. Have a good time. Bye bye.